Number 22, we got this Marcella character who is depositing $1,500 into a savings account, interest at an annual rate of 10%. No money is added or withdrawn from the account. That just means that whatever she started with, that's the number that's being compounded, and we aren't just throwing another 200 in every single year or something. That would change our equation. Write an equation to model the amount of money she has in her account. Okay, so basically we're using this equation right here, compounded interest. Okay, but I want to point something out. So in this case, what is n? N is, we have an annual rate. Okay, so you're getting that 10% one time every year. So n is just 1. What does that do to our equation? It makes it p times 1 plus r to the t, which is very much like a b to the x. Okay. It's just a version or a variation of our parent function. We have some growth rate, which is our constant multiplier. We have a principal or a starting amount, a or p, and then time, x is the number of times that we compound. Okay, so it's not a new equation, it's just in a different form. So the amount that we have, that Marcella has in her account, is 1,500 times 1 plus 0.1 to the t, or 1,500 times 1.1 to the t. All right, how much will be in the account after 20 years? This is one where you would use a calculator to do 1.1 to the 20th power. I figure most of you aren't just gonna, knock that one out, and that's okay. So you can leave it like that. The amount you'll have is 1,500 times 1.1 to the 20. The skill that we're measuring here is, can you create the equation and then use it? I know that if you can get that part, you can type it in your calculator correctly. Okay, I'm not concerned about that. I want to know if you can get to that point, if you understand the way the exponential equation is created and used. Okay. So then how many years will it take for the account to contain 4,500? Okay, 4,500, that is that's the amount at the end. We still started with 1,500. We're still growing at a rate of 10%. So what's the first one for? The first one is the 1,500 we put in there. The 0.1 is the extra that we get on top of that, to the t. Why is that the variable? Because it says how many years. That's a question. So t is what we don't know. All right, so this one you're going to divide by 1,500, and we find out that we're looking at tripling time here, basically. How long is it going to take us to triple? 3 equals 1.1 to the t. So now we need to change forms. We've got a log now. All right, we need a log because we have an exponent that has a variable in it. What's the base of our log? It's the same as the base of our exponent, 1.1. And then 3 is the number that goes in there, equals t. So there's your answer, and you can leave it like that. One thing that I see quite a bit is this, okay, equals 3. Okay, so that doesn't help us at all. Switching forms should help you. If you're switching forms, it's because you have a need that the exponential form isn't supplying for you. We can't figure out what that variable is if we leave it in exponential form. But if we switch it to log form and the t is right there, we still can't figure out what it is. Okay, we need the 3 to be in there because that's something we can type in a calculator. That's something we can figure out. Okay, so this is not correct, even though I see it a lot. Switching forms should help you find the answer, and that's not mathematically the reason, that's just practically the reason. It's a practical solution to this problem for us. If it was compounded quarterly, how long would it take to get 4,500? So we got the same equation, but quarterly means n is no longer 1. What is n? 1 plus the rate, 0.1, over what's n? It is 4 this time. So we divide by 4 to the 4t. We're still talking about the amount of time it's going to take us to triple. So that hasn't changed. What has changed is this number in here. So it's now, and you could do something like this. How many times will 4 go into 0.1? Well, it'll go into 1 0 times. So then we're going to have to add a 0. How many times will 4 go into 10? Twice. Got 2 left over. We're going to have to add another 0, bring it down. 5. 5 times 4 is 20. So that's this number here on the end is 0.025. 1.025. Okay. Gotta get real comfortable with the numbers. And then 4t is the exponent. So now we've got a variable in an exponent, so we need to get it out. We're going to do log base 1.025 of 3 is equal to 4t. And then we'll divide by 4 on both sides. And you get that the amount of time it's going to take to get there quarterly is the log 1.025 of 3 over 4. What I'm going to do is, real quick, I'm going to compare both of those numbers. For this first one, if you had a calculator, you would get about 11.53 years. No time at all, Marcella. And then for this one, you get 11.12 years. Okay, so the difference between compounding quarterly and compounding yearly, in this case for the tripling time, is a little less than half a year. Okay, so not a huge difference, but a difference nonetheless. If you're gaining money, I would rather be doing this quarterly. If you've got a loan, I would rather the loan was compounding interest as seldom as possible. I wouldn't want it to be compounding all the time, although they usually